It is represented by omega. Here, value of angular velocity, it is equal to angular displacement divided by time. If we talk about the average angular velocity, then it is defined as total angle traveled divided by total time. On the other hand, if we are talking about instantaneous angular velocity, then it can be given by d theta over dt. As from previous section, we had written angular displacement theta to be equal to arc upon radius. So, instantaneous value of angular velocity, it can be given by time derivative of angular displacement, which is s upon r. So it can be further written as 1 upon r ds by dt. Now here this ds by dt gives the tangential speed of the particle which is going under circular motion. So finally we may write omega to be equal to d theta over dt or v tangential divided by r. Direction of angular velocity is always along the axis about which particle is revolving. Use right hand thumb rule to get the direction of angular velocity or any other angular variables, because angular variables are axial vectors, means these vectors always points along the axis of revolution, means there may be only two directions, one in one direction and the second direction is just opposite to it, because these vectors are always along the axis of rotation. For one case, we have taken anti-clockwise rotation. For this anti-clockwise revolution, direction of omega goes up the axis, and in case of clockwise revolution, the direction of omega goes towards down. Sense of rotation can be very easily understood here. To clear the concept associated with this particular angular velocity, we can do it easily by using a very simple example which I am taking. This example, there are two particles separated by distance r from each other. This is called particle A and particle B. Velocity of particle B is given, the linear velocity of particle B is given to be 6 meter per second, and the velocity of particle A, it is given to be 8 meter per second. A moves at an angle 30 degree from this line AB, and B also moves at an angle 30 degree with the line AB with velocity 6 meter per second. Here value of distance between A and B is given to be 10 meter. Now we have been asked angular velocity of A with respect to B. Now you can see it in quite a different manner because I have to solve for angular velocity of A, but it is relative to B. As we know, velocity of A with respect to B can be written as velocity of A minus velocity of B. Here V and VB are directed just opposite to each other because this angle is 30 degree, this angle is 30 degree. We can say these two velocities are parallel but in opposite directions with respect to each other. So, while calculating velocity of A with respect to B, we will use just the basic definition of relative velocity, which is VA oblique B means velocity of A with respect to B, it is equal to VA minus VB, where VA and VB are velocities of A and B respectively with respect to ground. So, relative velocity of A with respect to B now becomes 8 minus 6, because this is opposite to this. We got velocity of A relative to B 14 meter per second. We can picturize this situation in quite interesting way. This is say A, this is B. So here situation now converts as velocity of B relative to itself will be 0 and velocity of A with respect to B is 14 meter per second as we have calculated on the previous page, and this angle is 30 degree. Then the situation just becomes that particle B is at the center and particle A is revolving around it. As we know, angular velocity is omega, which can be written as Vt divided by R. What is Vt here? This Vt is velocity of particle perpendicular to radius R. So here, if we use this Vt, we can easily say, so component of this velocity VAB, which is 14 meter per second, if we resolve it in two mutually perpendicular directions, one perpendicular to the radius and other along the radius, we got 7 under root 3 and the other component is 7 meter per second. Here, this is the velocity which we have to use in our further calculations, because this is the component which can be treated as Vt under the given condition. So, omega is equal to Vt by R, or omega can be written as 7 upon 10 means 0.7 radian per second. The main conclusion of this entire part is to clarify the Vt. It is not velocity of the particle, it is component of velocity of particle perpendicular to the radius vector. So remember, this is an important relation which you have to use in various conditions. So I think you got the complete solution for this lecture, and I wish you got understand also.